Hello. Today we are going to look at a couple of different tables and we're going to try to figure out what the values that are missing in these tables are. So in my first table you can see I have the ordered pairs 1, 4, 2, 5, 3, 6, 4, 7, and 10 question mark. And as we look through these, as you look through my X's, you can see that as I go from 1 to 2, 2 to 3, 3 to 4, that I'm increasing each time by 1. So my X's are just kind of adding 1 each time, and we're going to try to use that information to figure out what it is when I plug in for 10. So when I go for 4 to 5, 5 to 6, and 6 to 7 again, I'm just adding 1 each time. So that indicates to me that if I were to keep going, all I would continue to do is add 1 each time until I get to 10. So I would be sitting at 5, 8, 6, 9, 7, 10, and so on, up until I got to 10. But if you look at this, there's another pattern here, and I'm just going to, each time I take my X, whatever my X value is, I'm going to add 3 to it, and each time that's going to get me Y, whatever that is. So if I were to plug in, say, 1, if I were to plug in the number 1 and add 3 to it, I get 4, which is Y, and which is where the 1 comma 4 comes in. Okay? Another way to look at this is, another way I can write this is in functional notation. So instead of x plus 3 equals y, I could say f of x equals x plus 3, and that way you can see that when I do something like f of 2, which f of 2 right here, my input is 2, my output should be 5. If I do 2 plus 3, I do indeed get 5. Okay? So that's the pattern for this, right there or right here. So what do I get when I do f of 10? When I put 10 in, well, we're just going to do 10 plus 3, so the question mark should be 13. And that's the first one. Okay, so let's look at the next one. And you can see again that as I go from 1 to 2, 2 to 3, 3 to 4, then I'm just going to add 1 each time like before. But this time from 2 to 4, from 4 to 6, 6 to 8, I'm adding a little bit more than 1. I'm adding 2 each time. And because I'm adding 2, what that will tell you is that what's happening here is there's going to be some sort of multiplication. In fact, whatever I take for my x, because I'm adding 2 each time, I'm actually going to do 2 times whatever x is. And now let's test this as we have it. If I were to do, say, 2 times 1, like if I input x to be 1, what do I get? 2. Well, there it is. My result is 2. So my 2 times x equals y, or, like before, I can rewrite it in functional notation, f of x equals 2x. And then we just figure out now what's going to be 10. So f of 10 equals 2 times 10, so we get 20. So the question mark in that one is 20. All right, and then in the last one, we're going to look at pretty much the same stuff. So my x's from 1 to 2, 2 to 3, nothing's changed here, still adding 1. And here from 5 to 7, I'm adding 2. From 7 to 9, I'm adding 2. From 9 to 11, I'm adding 2. Okay, so again, we're going to have some sort of multiplication going on. So whatever my x value is, I'm taking it times 2 because of these plus 2's. That's where this comes from. These right here is where we got this 2. So I'm doing 2 times x. But this time, if I do 2 times 1, because if I plug in x equals 1, I only get 2, and I should get 5. So what do I have to do yet to the 2 to get 5? I'm going to go plus 3. Okay, so that should give me my y value. And let's test another one just to be sure, because this one seems a little bit more complicated. So let me grab my green marker here. All right, and let's try 2. So if I do 2 times 2 plus 3, okay, that's equal to y. Well, 2 times 2 is 4 plus 3 equals y. So 4 plus 3 is 7. So when I input an x of 2, I should get a y of 7. And sure enough, I do. So there's my function right there. And it's f of x equals 2 times x plus 3. And then we will input that. So we'll go to orange, and we want to do f of 10. So we do 2 times 10 plus 3, and the result is 23, and we are done.